Hey, good morning, good afternoon, everyone. Today, I'll be presenting our work on Zero Trust Health Care Data Exchange using permission blockchain. My name is Harshendra Gite, and my co-authors are Neha Sharma and Anupam Tiwari. This research focuses on improving security, privacy, and trust in healthcare system. Next slide. The challenges, the traditional system follows one side always trust model, which is risky. Multiple parties, hospitals, insured, shared data through centralized systems. This leads to um, insider threats, credential misuse, and then weak or tampered audit logs. Moving on to the next slide. Motivation. The healthcare data is highly sensitive and must be accessed only by the right users at the right time. Existing um, logging machines can be altered, so audits are not always reliable. We need a trustworthy tampered proof framework for across organizational data securing. Um, Moving on to the key idea here, we combine zero trust for strict access control with blockchain for blockchain uh, blockchain auditability. Every request is verified, not implicated. Trust is assumed. All access decisions are immutably recorded or accountable. Moving on to next slide, the contributions. Mainly the contributions are categorized into four layers, that is zero trust framework, blockchain audit layer, off-chain data storage, and prototype evaluation. So basically zero trust that validates identity, role, purpose, and context. Then blockchain layer that records um, all access decisions immutably, and then off-chain storage actual data to maintain privacy. So this is about the contributions. The system architecture, there are three layers in the system architecture. Zero trust security blockchain audit, off-chain storage, and then stakeholders are the hospitals, lab, insurer, and regulator. Security, accountability, and data storage are separated for efficiency. Coming to system model, uses a permission network, role-based, role-based, role-based with least privilege enforcement and metadata only. Who, what, when decisions, not patent data. Coming to threat models, uh, if you see authorized access, insider misuse, replay attack, log tampering are mainly the threats here. So our design counters this using continuous verification plus immutable logs. So that's how we have ensured threat models are uh, being taken care of. So coming to our design goals, there are again four types of design goals, that is least privilege, continuous verification, tampered proof audit, and low tenants latency. So if you look at right, only necessary access is granted through our least privilege, and then every request we have continuous verification. Blockchain are tamper proof through audit through tamper proof through auditing, and then we have practical use to maintain low latency. Coming to next slide, identity and trust. Uh, User have role-based identity like a doctor, and lab tech, and then insurer, etc. All requests are digitally signed, ensuring authenticity and non-repudiation, and no network-based trust, which is like identity becomes the new parameters. So this is how the identity and trust has been established. So this talks mainly on the zero trust identity and access controls. Moving on to policy. Enforcement. Access is checked through uh, roles, purpose, and then organizational boundaries, and then secured, consistent, and then auditable decisions. That's how the policy enforcement is done to multi-layer policy check and ensured security and compliant access. So that's how this has been gained. Coming to the next slide, permission ledger. So the blockchain uses hash chain, making tampering detectable, and then Merkle tree for efficient verification. Only metadata is stored, ensuring the privacy and then compliance. This is how this has been taken care. Coming to um, the next slide, which is like we are talking mainly on the workflows. The workflows are step by step, which is like request, sign, verify, authorize, and lock commitment. Every step is mandatory, no bypass allowed, and so that the performance is not impacted. That's how the workflow is ensured. Coming to experimental setup, so the prototype built in Python with 300 test requests, 25% invalid requests simulate real world attack, and then metrics um, measured latency through and commit time. So that's how the experiment was set up, so that the blockchain's range are taken care between 100, 10 to 200, and then evaluation matrix was sorry, performed. The next slide talks mainly on the result latency. The result latency, the verification latency is less than 0.03 millisecond, extremely fast. Blockchain does not add delay to decision making, shows the strong, secure security can still be highly responsive. Coming to the results, throughput. Throughput improves with large block sizes. System stabilized at higher load, showing scalability. Batch reduces per transaction overheads. Coming to result commit time. The result commit time increases linearly, which is like predictable and manageable. Around 5 milliseconds to 200 transactions, still very efficient. Confirms system can scale without performance. Moving to the key findings, the security is maintained regardless of batching. Zero trust principle remain intact. Blockchain provides reliable auditability with low overheads. That was our key finding. Coming to limitation, uh, the, uh, the tested on single node setup only, use synthetic data instead of real time patient records. Multi node distributed performance not yet evaluated. Then um, when we move on to the future work, extend to multiple node blockchain environment, real world healthcare data sets, and add adversarial testing, and then consent based access control. Conclusion, basically the system is secure, auditable, and scalable, achieves strong security and minimal performance impact, suitable for real world healthcare data exchanges. This is how the future work has been established. And then coming to the conclusion, basically this is like secure, auditable, and scalable, as I mentioned to you. And then the real world healthcare data exchanges are uh, very much secured, and there is no tampering of data. So that brings us to the end of this paper presentation. And thank you everyone for your attention. Yeah, anything that you have, please forward your questions to us, and we will ensure that the appropriate response is shared either through emails or through appropriate response. Thanks again. Have a great day ahead.